Hi dear students, today I am going to start the exercise 9a of chapter Triangles chapter 9a. In this exercise, based on the congruency, you are going to solve all the sums. In previous lecture, you people studied about the congruency, that is SSS congruency, SAS congruency, ASA congruency, AAS congruency and RHS congruency. Based on that, today you are going to solve all these sums. See, let us see the first question. Which of the following pairs of triangles are congruent? In each case, state the condition of congruency they mentioned. Means here, they given some questions here in these among these questions. See here, in the first question you want to check that whether the given pair of triangles are congruent. If they are congruent, on what condition of congruency they are congruent, you want to mention here. See here, the given in triangle ABC and triangle DEF, two triangles are given. In this, they given that AB is equals to DE, BC is equals to EF and angle B is equals to angle E. Two sides, the corresponding two sides corresponding angle, they given equal or not. You people first you need to check that one, and then with the congruency rule, you people need to write these two triangles are congruent now. See here, check here, AB is equals to DE they given, and again BC is equals to EF they given. AB, DE and BC, EF and angle B is equals to angle E they given. See here, observe here, whatever the corresponding sides which are equal here, that corresponding side included angle is also equal, that is angle B is equals to angle E. Now which congruency rule you can apply to tell that these two triangles are congruent means that is SAS congruency. Let's write down in triangle ABC and triangle DEF, what the given is AB is equals to DE, next BC is equals to EF. For these two sides the included angle is B and for these two sides the included angle is E, that is angle B is equals to angle E. See, now you can tell that all this given data only. Therefore, according to SAS congruency, you can mention that triangle ABC is congruent to triangle DF. Now on the condition of SAS congruency, these two triangles will become congruent. Now let's move for the next question, B1. Again check the B question here. In the B question, again in triangle ABC and triangle DEF, what the given is angle B is equals to angle E and the two angles are equals to 90 degree they given, and again AC is equals to DF they given and BC is equals to EF. Now on what condition these two triangles will congruent, you need to check now. First draw the two triangles. See here, the one angle is 90 degree means obviously the two triangles are right angle triangle. Let the first triangle be ABC. Here the angle B is equals to 90 degree. And again the second triangle is DEF. Here the given angle E is equals to 90 degree and they mentioned that AC is equals to DF and again BC is equals to EF. Observe here, the side opposite to the 90 degree, AC is the hypotenuse and again the side opposite to the 90 degree, DF is the hypotenuse, and the given that the two hypotenuse, whatever the hypotenuse are there, the two sides are also equal. Now see, right angle hypotenuse and again one more side also equal, right angle hypotenuse side. Congruency, you can tell that these two triangles are congruent. angle B is equals to angle E. It is equals to 90 degree right angle, and again AC is equals to DF hypotenuse, and again BC is equals to EF. This is the among these two sides, one side is equal right angle hypotenuse side. According to RHS congruency, you can tell that triangle ABC is congruent to triangle DEF. Next, move on to the next question. In the same question only, sub question C. See here, in triangle ABC and triangle QRP, AB is equals to QR, angle B is equals to angle R the given, and angle C is equals to angle P the given. Now write down the given data. Triangle ABC and triangle QRP. What they mentioned, AB is equals to QR the given, angle B is equals to angle R the given, and angle C is equals to angle P the given. Now draw the two triangles. A, B, C, and again one more triangle is Q, R, P. See, in this they given that AB is equals to QR, and again they mention angle B is equals to angle R, and again angle C is equals to angle P. See, in these two triangles the two angles are equal. The two corresponding angles are equal, the given, that is angle B is equals to angle R, angle C is equals to angle P, and again one more side AB and QR equal, the given. Here what is the congruency rule you can apply to prove that triangle ABC is congruent to triangle QRP? Means here AAS congruency you need to apply here, because here see here these angle B, angle R, angle C and angle P, what is the included side is BC and the RP. If the given that BC and the RP are equal means, then you can apply the ASA congruency, because this side will become the included side for these two angles. But here the given that AB is equals to QR, which is not included for these two angles, so you need to apply the AAS congruency in triangle ABC and triangle QRP. Now angle B is equals to angle R, angle C is equals to angle P, now and again AB is equals to QR. So all are the given datas. Now AAS congruency condition can tell the triangle ABC congruent to triangle QRP. Let's move for the another question. See here, in triangle ABC and triangle PQR, AB is equals to PQ, AC is equals to PR the given, and BC is equals to QR. This is the easiest one. See here, all the sides are equal, the given. Triangle ABC and triangle PQR, what the given is, AB is equals to PQ the given, AC is equals to PR the given, and BC is equals to QR. Draw the two triangles, that is ABC, and again the triangle PQR. Now the given AB is equals to PQ and again AC is equals to PR, BC is equals to QR. That is AB is equals to, in triangle ABC, first you people need to mention whatever the triangles or need to prove. First you need to mention here whatever the triangles you people need to prove the congruency. First you need to mention here in triangle ABC and triangle PQR. Then according to the congruency condition you need to prove that these two triangles are congruent. First it's need to mention that whatever the triangles you people are taken in here. AB is equals to PQ, and again AC is equals to PR, BC is equals to QR. All these are given in the given data. Now SSS congruency condition can tell that triangle ABC is congruent to triangle PQR. Next, move on for the last question in the second one. See what is the given question is. In triangle ABC and triangle PQR, BC is equals to QR, the given angle A is equals to 90 degree, angle C and angle R is equals to 40 degree, and angle Q is equals to 50 degree, the given. From this given data you need to prove that triangle ABC and PQR are congruent with congruency condition. That is triangle ABC and triangle PQR. BC is equals to QR, the given angle A is equals to 90 degree, and again the given angle C is equals to angle R is equals to 40 degree, and angle Q is equals to 50 degree, the given. Now draw the two triangles ABC and the second triangle PQR. Here the given BC is equals to QR. Now here in the first triangle the given angle A is 90 degree, and again angle C and angle R is equals to 40 degree, the given, and again in the second triangle PQR angle Q is for 50 degree, the given. See now the given that one angle is equal and again one side is equal, but we need one more element to prove the two triangles are congruent, because minimum 3 elements need to prove that two triangles are congruent. Here only the 2 elements are there, means here one more element is required here. See how you are going to find out that one more element means, check in the triangle ABC. The sum of these two angles, according to the angle sum property, what is the sum of all the 3 angles of a triangle is equals to? It is equals to 180 degree. Now sum of these two angles is equals to what? 90 degree plus 40 degree, you will get the 130 degree. And again what is the angle of the third side, angle B? 180 minus 130, you will get the 50 degree here. Now if this angle become the 50 degree, this angle will become equals to angle Q, and again already they given that angle C is equals to angle R. Now BC and QR will become the included side for these two angles. You can apply the ASA congruency condition. Now find out this angle B now in the triangle ABC. Now in triangle ABC, according to the angle sum property, sum of all the 3 angles is equals to what? 180 degree. The given angle A is 90 degree, angle B and angle C is 40 degree, equals to 180. 90 plus 40 is what? It is 130 degree, equals to 180. That is, it will become 180 minus 130. Now angle B will become the 50 degree. Now you can prove that these two triangles are congruent according to the condition of ASA congruency. Now let's take the triangles in triangle ABC and triangle PQR. That is, angle B is equals to angle Q 50 degree. Here we already proved here 50 degree. Angle C is equals to angle R 40 degree. The given, and again included side BC is equals to QR. ASA congruency. ASA congruency. You can tell that these two triangles are congruent. Triangle ABC is congruent to triangle PQR. Now this is the end of the second question. Now can move for the third question. See, what is the third question they given here? They given the circle here. The given figure shows a circle with center O. P is the midpoint of chord AB. The given show that OP is perpendicular to AB. You need to prove that OP is perpendicular to AB. First, let us draw the given diagram. What the given is? The given the circle with center O, and the given the chord AB. People already know about the chord. The line joining any two points on the circumference of the circle, going to call that line as the line segment as the chord, and the given that P is the midpoint of the chord. And if you draw a line from the center O to the midpoint of the chord AB, then that line will become perpendicular to the chord you need to prove in this question. Okay, that is, you need to prove OP is perpendicular to AB. Here P is the midpoint of AB, therefore the length of AP and the PB will become equal now. See, now first step, whatever the given here, AB is a chord, P is midpoint of AB. So therefore this implies what? AP is equals to PB. Now here one construction you need to do to prove OP is perpendicular to AB. What is that means? Here join OA and OB. You need to join the OA and the OB here. Join here now. See here, after joining this one, you will get the two triangles. That is triangle OAP and triangle OBP. Now take these two triangles and prove that these two triangles are congruent. After proving that these two triangles are congruent, you will get this angle will become, according to the CPCT, these two angles will become equal. Later on, let's see how you are going to prove this one. OP is perpendicular to AB. Proof. First again, what you are going to write is to prove that OP is perpendicular to AB. Now proof. How are you going to prove this one? Let's consider whatever the triangles you are taking here in triangle OAP and triangle OBP. See here, whatever the corresponding sides and corresponding angles are equal. See here, OA is equals to OB. In the triangle OAP, OA. In the triangle OBP, OB. These two sides are equal. Why? What is the reason? Because that two sides are radii of the same circle. Therefore, the length of the radii is always equal. Radii of same circle. And again, here observe the OP here. OP is common for both the triangles OAP and the OBP. You can write OP side is common for both. Therefore, OP is equals to OP you can write. You got the two sides are equal. And again one more element is here the given that P is the midpoint of the chord AB. Therefore, the length of the AP and the PB is also equal. It is given. Now, on which congruency condition these two triangles will become congruent now? According to the SSS congruency condition, you can tell that triangle OAP is congruent to triangle OBP. Now, what we need to prove? After proving these two triangles are congruent, we need to prove that OP is perpendicular to AB now. See, for that what we need to do means first take the whatever the congruent part of the congruent triangles are equal. Let's check first one. See, all the three sides are equal. By taking this one, you prove that these two triangles are congruent. And remaining, what are the three elements are remaining here? The angles. The corresponding angles are also will become equal now because these two triangles are congruent. And remaining three elements are what are there? Three angles. The three angles are also become equal now. Now, I will take that angle OPA and angle OPB is equal. Angle OPA is equals to angle OPB. This is the congruent part of a congruent triangle. From this, these two angles will become now equal. Now, see, how are we going to prove that by these two angles are equal? Now, how are you going to prove that OP is perpendicular to AB? For that, you want to take that AB line. AB is a line. See, observe here. AB is a line. See, on the AB line, complete whatever this angle is forming here, this complete angle is equals to 180 degree. That is angle OPA plus angle OPB. It is equals to 180 degree. And by combining these two angles, it is forming a straight line, means you can tell these two angles are linear pair. That is angle OPA plus angle OPB is equals to 180 degree because by combining these two angles, it is forming a straight line here. Therefore, you can tell that the two angles are linear pair. Now, here already we proved in this. Here, according to the CPCT, these two angles are equal. See, from this condition, you can substitute in the place of OPB or OPA one angle. Now, I am going to write in the place of OPB as OPA because the two angles are equal. Now, angle OPA is equals to OPA is equals to 180 degree. You can call this one as 1 and you can mention it is from 1. Now, angle OPA plus angle OPA will get the 2 times of angle OPA equals to 180. Angle OPA is equals to 180 by 2. Let's divide this one. What you going to get? This angle OPA as 90 degree. Now, this angle will become the 90 degree. What about this angle OPB? That angle will also become equals to 90 degree. From this, you can tell that OP is perpendicular to AB. Hence, proved. This is the end of this third question. Now we can move for the fourth question. See, what is the fourth question? The given is the following figure shows a circle again. Again they given the circle with center O. OP is perpendicular to AB. They given. You want to prove that AP is equals to PB. This will become the converse of this one. See, check here. This question will become the converse of the question third. Here the given is P is the midpoint of chord AB. if a line drawn from the center O to the midpoint of AB means it will become the perpendicular to AB. Here the given that the line drawn from the center to the point on the AB means it will become the perpendicular means that point will bisect the AB. Now this question will become the converse of third question. Now first draw the given figure, draw the circle, mark the center O, draw the chord AB, mark the point P. From the center O, draw a line which is perpendicular to AB. Now you want to prove that P is the midpoint of AB. That is, the length AP is equals to PB you need to prove. Whatever the given, write down first. O is the center of the circle, the given, and the given that OP is perpendicular to AB. This will give that angle OPA is equals to angle OPB is equals to 90 degree. What you need to prove? You need to prove is AP is equals to PB or P is the midpoint of AB you need to prove. Here also you need to do the construction. What is the construction you need to do means here also join OA and OB. Join now OA and the OB. After joining this OA and the OB, you will get the two triangles here. See, by taking these two triangles and after proving these two triangles are congruent, obviously by CPCT you can get this AP is equals to PB. Now proof. Take the two triangles which you need to prove the congruency. In triangle OAP and triangle OBP. Now write down the whatever the corresponding sides and angles are equal. Mind the given that angle OPA is equals to angle OPB is equals to 90 degree the given. Observe here, then the side opposite to the 90 degree OA and the side opposite to the in triangle OBP 90 degree OB, these two also equal. Why? Because both are radii of same circle. In the same way, the side opposite to the 90 degree, they will become the hypotenuse now. Hypotenuse are equal now. Now you are getting that which congruency rule here you are going to apply. And again, OP is equals to OP. Both also common side. Now which congruency rule you can apply here? Right angle hypotenuse side, that is RHS congruency. You can tell that triangle OAP is congruent to triangle OBP. Now by CPCT, the corresponding remaining part of the corresponding sides are also equal, that is AP is equals to PB. This is from CPCT. What they asked the question is we proved here. Next, move on for the next question, that is fifth one. See now what is the fifth one is. Observe the fifth one. In triangle ABC, what the given is, in triangle ABC, let draw. They not given the figure here, but we need to draw that one. In triangle ABC. In triangle ABC, D is the midpoint of BC they given. D is the midpoint of BC they given. And again, AD is produced up to E. so that DE is equals to AD. Means join this AD and again you need to produce till up to it in such a way that whatever the length of AD is there, that length will become equals to the length of the DE. Till that you need to extend the length of the AD. Now AD and the DE are equal, the given. And again they asked to prove that so that D is equals to AD. They asked to prove that triangle ABD is congruent to triangle ECD, they asked. Now ECD they are asking to prove congruency with the triangle ABD, means you need to join the CE here. Join the CE and you need to prove these two triangles are congruent. Now find the first question. Okay. Now the first proof, what they asked, triangle ABD is congruent to triangle ECD, you need to prove. Let's take the two triangles. In triangle ABD and triangle ECD. Now whatever the congruency conditions are there, check that one. In what condition these two triangles will become equal now? First of all, they given that the length of the AD and the length of the DE both also equal. That is, let's write down that one. AD is equals to DE. It is given. Next. And they mentioned that D is the midpoint of BC. D is the midpoint of BC means what about the length of BD and the DC? The two sides will also become equal. BD is equals to DC. One more side you got, because D is midpoint of BC. And again here you got the two sides. Now check this angle. What about this angle is? This angle is vertically opposite angle. Vertically opposite angle is also equal. See, for this AD and the BD, this ADB angle is the included angle, and again for ED and the CD, and this angle will become the included angle. Along with two sides, the included angle also will become equal, means on what condition you can tell that these two triangles are congruent? SAS congruency condition. That is, angle ADB is equals to angle EDC, because why? It is vertically opposite angles are always equal. Now according to SAS congruency, you can tell that triangle ABD is congruent to triangle EC. The first proof is over. Now what is the second they ask is, see here, the second proof they asked is, you need to prove that AB is equals to EC. AB equals to EC. It's a easy one. You can to prove AB equals to EC, because why means AB equals to EC, because it is the, from this you can tell that AB equals to EC. The remaining, whatever the congruent part of a congruent triangle is also equals, that is from CPCT. See, here you can mention it as 1 from 1, because from 1, that is triangle ABD is congruent to triangle ECD. From the CPCT you can tell that AB is equals to EC. The second proof is also over now. Now you want to prove that AB is parallel to EC. AB is parallel to EC. You need to prove in the third condition. Now how are you going to prove that AB is parallel to EC? The third proof is Need to prove that AB is parallel to EC. Now check here. These two triangles are congruent, means whatever the remaining part of the congruent triangles, that also equal. Now I am going to take that here, see, this angle will become equals to this angle, we know. And again here the BD is equals to DC is equal, because here D is the midpoint of BC. Whatever the angles opposite to these two equal sides, what are the angles? That is angle BAD. And again for this side, which is the angle opposite to this one, is DEC. This corresponding angles are also equal. From the CPCT I will take that one, that is angle BAD is equals to angle CED. That is because triangle ABD is congruent to triangle ECD. From this you can write these two angles are equal. By taking these two angles are equal, what is the use of these two angles? To prove that AB is parallel to EC. People know about the two parallel lines, and again the transversal. If you draw a line passing through the two parallel lines, that line will become the transversal for both the two parallel lines. And here whatever the angle formed at the point of transversal where it touches the parallel lines, so many angles are formed. In that you people know about the interior alternate angles, that is angles on the either side of the transversal. See the angle formed on the either side of the transversal, that is here alternate angle, means like this, two parallel lines and the angles are formed on the either side of the transversal, that angles are always equal. Like this in the Z form, whatever the angles formed at the corner here, we are going to call these angles as the alternate angles. Here what is the use of this angle means, check here also. Now AB is the line, and again consider C is also the line, and again and AE is the line, it is passing through the AB and the CE. Yes or no? Here AE is the line is passing through the AB and the CE. Here also observe that what is forming here? The Z forming in the form of Z. Whatever the corner angles here, that is BAD and again CED. These corner angles are equal now. Now at what situation these two angles are equal? When these two lines are parallel only, in that situation only these two angles are equal. If these two lines are not parallel, means these two angles are never equal. If the here for the two parallel lines and one transversal line is passing through the two parallel lines, means always the interior alternate angles are always equal. You can tell. The same way here you are going to apply this one as AB and CE are two lines. First we don't know that AB and CE are parallel or not, but AB and CE are two lines, and again AE is passing through both. AB is passing through both AB and CE. AE is passing through both AB and CE, means now I can tell that AE is a transversal. AE is a transversal like this. Okay. Now consider like this the Z form. Here also it is forming the Z form. Whatever the corner angles here, these corner angles are equal. Because of triangle ABD and triangle ECD are congruent, these two angles are equal. Now take these two angles, that is angle BAD is equals to angle CD, which we can call these two angles are interior alternate angles. By this you can tell that AB is parallel to CE. When these two angles are equal means when this AB is parallel to CE, in that situation only these two angles are equal. Otherwise these two angles will never equal. This is the end of the question 5.